All right, let's dive in. Today, we're going to talk about one of the biggest shifts in the history of human thought, the scientific revolution. Now, this isn't just a story about new discoveries, like telescopes and falling apples. It's the story of how we as a species literally learned to see the entire universe in a completely new way.
You know, the historian Herbert Butterfield, he absolutely nailed it. He said that to even begin to understand this period, you have to imagine putting on a different kind of thinking cap. It wasn't about just learning new facts. It was about throwing out your old mental operating system and installing a brand new one. And that idea, that thinking cap, is what we're going to keep coming back to.
And that really is the heart of the problem, isn't it? The medieval worldview, the one that came before the revolution, it wasn't just a bunch of random superstitions. No, it was this incredible, coherent system and had an answer for literally everything, from why a rock falls to why the stars move. So how in the world do you even start to take something like that apart?
To really get what they were up against, we have to understand that old worldview. And it's so important to remember this system wasn't seen as primitive. It was considered a colossal intellectual feat. It was logical, it was elegant, and for centuries it had an iron grip on how everyone saw the world.
So this medieval universe was all about order, hierarchy, and purpose. Right at the very center, you had the Earth, made of the four elements. You had solid Earth, the meanest stuff, then a sphere of water, then air, and then fire, the most noble of the four. Everything down here, below the moon, was messy. It could change, it could decay, but up there in the heavens, that was the realm of perfection. Perfect, unchanging crystal spheres that never, ever changed.
Well, what kept the whole thing moving? The answer was something called the primum mobile, the first mover. You can think of it as this massive, invisible, outermost sphere. It was seen as the grand engine of the cosmos, moved by the highest spiritual beings, and it was its job to turn all the other spheres inside it, wheeling the sun, moon, and stars around a completely stationary Earth once every 24 hours.
Now, what's so fascinating is that the first real crack in this perfect system, it didn't come from looking up at the stars. It came from a much more down-to-earth question, something you could test yourself. If you throw a rock, what keeps it moving after it leaves your hand?
Okay, so there were two totally different answers to this. Aristotle's view was that the air itself rushed around behind the rock and kept pushing it forward. For him, motion always required a constant external pusher. But then this new idea started bubbling up, called the theory of impetus. It said, no, the person throwing the rock actually imparts a force into the rock, an internal drive that it carries with it, and that slowly fades. This was a complete game changer, because for the first time, motion could be a property of the object itself.
And the implications of that simple idea were, well, they were astronomical. A scholar in Paris named Jean Buridan had this incredible insight. He realized that if impetus was real, maybe you don't need angels or intelligences constantly pushing the planets around in their orbits. Maybe God just gave each planet an initial push at the beginning of time, an impetus, and because there's no friction in the heavens, they would just keep moving, forever. All of a sudden, the engine of the cosmos didn't need a constant operator.
So the problem of motion started a crackdown on Earth, but the real knockout blows to the old cosmos, those came from the sky. Thinkers like Copernicus and Galileo, they weren't just trying to tweak the old model. They were taking a sledgehammer to the crystal spheres themselves.
And this wasn't a quick fight. It was a battle that raged for almost a century. It kind of starts quietly in 1543 when Copernicus publishes his sun-centered model. Then, in 1610, Galileo gets his hands on a new invention, the telescope, points it up, and starts collecting devastating evidence. By 1632, with his book Dialogues, he's not just suggesting an alternative anymore, he is openly and directly attacking the old system.
And what did Galileo see? Just an absolute flood of game-changing evidence. Every single observation was like a dagger to the heart of the old cosmos. The heavens are supposed to be perfect, right? Well, the moon has mountains and craters just like Earth. They're supposed to be pure and unchanging. The sun has spots that move and change. Everything is supposed to orbit the Earth? Nope, Jupiter has its own little moons circling it. And maybe the killer blow, Venus goes through phases just like our moon, which only makes sense if Venus is circling the sun. The evidence was just becoming impossible to ignore.
But remember, facts alone are rarely enough to kill a worldview that explains everything. To really replace it, you need a whole new way to find the truth. You need a new method for thinking. You need that new thinking cap.
And two absolute giants, Francis Bacon and René Descartes, basically offered two different toolkits, Bacon said we need to be like bees, go out into the world, gather data from experiments, that's the pollen, and then process it into real knowledge, the honey. Descartes, on the other hand, argued for the complete opposite approach. He said we have to start by doubting everything, throw out all our old beliefs, and rebuild our entire understanding on one single rock-solid foundation of pure logic. I think, therefore I am.
And this all led to what is maybe the most profound shift of all. It was Galileo who said, "The book of the universe is written in the language of mathematics." What he meant was that the real qualities of the universe weren't things you experience, like color or taste or smell. The real fundamental qualities were the things you could measure: size, shape, motion. Just think about that. This shift to a purely quantitative view of reality, it's the bedrock of all modern science.
So at this point, we have all these different pieces lying around. A new idea about motion, shocking new observations of the sky, new philosophical toolkits from Bacon and Descartes. The world was waiting for someone to put the whole puzzle together into one new, coherent picture. And that person was Isaac Newton.
Newton's masterpiece was his law of universal gravitation. With one single, breathtakingly elegant equation, he showed that the force that makes an apple fall from a tree to the ground is the exact same force that holds the moon in its orbit around the Earth. Just like that, the ancient wall between the messy, corruptible Earth and the perfect, unchanging heavens was gone. It was one universe, all of it governed by the same universal, predictable laws.
This new scientific worldview had consequences that rippled out far beyond science. It fundamentally changed how people saw their place in time and in history. It actually gave birth to a brand new and totally revolutionary concept, the idea of progress.
See, before the revolution, history was seen as cyclical. The general view was that the giants of the past, the ancient Greeks and Romans, were the peak of human achievement. The best moderns could hope for was to maybe imitate them. But the scientific revolution flipped that script. People started to see knowledge as something that builds on itself, that accumulates over time. Thinkers like Bacon argued, hey, we are the ancients, because we stand on the shoulders of everyone who came before us. And for the first time, Western civilization began to believe that its future could actually be better than its past.
So in the end, this incredible revolution wasn't just about discovering the laws of physics. It was about discovering a method for changing our minds based on evidence. It gave us a process for taking off one thinking cap and trying on a new one. And that leaves us with one last question to think about. What parts of our own worldview today, the things we take for granted as obviously true, what parts might just be waiting for a new thinking cap?